So, one advantage of scientific notation is it's going to eliminate this problem of whether 0 is significant or not significant. So that's another reason why I recommend you leave your calculator in scientific notation. In scientific notation, remember, if I wanted to write the number 470 with the decimal point, I have to move over 2 places, and that 0 with the decimal point was significant. So in scientific notation, I write 4.7, and I do include the 0, and I had to move the decimal over to the right, or to the left rather, 2 places, so that's 4.70 times 10 to the second. On the other hand, the number 500, there is no decimal point, but it would have been here, so I go over 2 places. Those zeros are not significant, so I don't include them when I write the scientific notation 5 times 10 to the second. Notice, once we have it in scientific notation, we can count sig figs only by looking at this part of the number. We never look at the times 10 to the exponent. This is the only part we count for sig figs. So I have 1 sig fig in 5 times 10 to the second. There's no ambiguity about the zeros counting or not. In the number 4.70, this is a trailing 0. The number has a decimal point, so I have 3 sig figs. You cannot change the number of sig figs when you change the notation. If I have 3 in normal, I have to have 3 in scientific. If I have 1 in normal, I have to have 1 in scientific. And that's going to go forwards and backwards. So if I wrote the number 5 times 10 to the second, I have to write that as 500 with no decimal point. Now, sometimes a measurement can look like it only has 1 sig fig. In the example, if you measure the number of children that you have, you come up with 3. 3 looks like there's only 1 sig fig. But this number of 3 children, this number has absolutely no uncertainty about it whatsoever. If you count the number of kids you have, I doubt you have any uncertainty about that. So it's not any more precise to say, oh, you have 3 kids, but I have 3.0000 kids because I counted mine more precisely. This is an exact number or a counting number, and exact numbers or counting numbers have an infinite number of sig figs. It's very similar to a definition. If you had a dozen pencils, 1 dozen is equal to 12 pencils. And for things that are exact or definition, we're going to write that in this class not just as a normal 2-bar equal sign, but rather a 3-bar equal sign. This means 1 dozen is defined as exactly 12. You'll see this in conversions that we're going to be working with quite a bit later on this chapter. 1 inch is exactly 2.54 centimeters. So I will give you conversions in this format, which is slightly different than how the text writes this. The text would say 1 inch, they have a normal equal sign, 2.54 centimeters, but then they'll have to add the word exact in parentheses. So on the exams and on your formula sheet, you'll see it written this way if it's an exact relationship. If it's not exact, then we're going to use a normal 2-bar equal sign, such as a pound is approximately 454 grams. This means the two things are equal, but they're not defined in terms of each other. It's not an exact relationship. So if we put this together and we look at these examples, how many sig figs in this first measurement of liters? So we have trailing zeros, and there is a decimal point, so these zeros will count. We also have a 0 in between the 5 and the 6, so that one's going to count. So this one has all 7 digits being significant. The number 90 grams is also a trailing 0, but there is no decimal point. So the only thing that's meaningful is the 9. That's just one sig fig.